Hello everybody, this is Coach Meinbauer here for the video on AP Pre-Calculus 4.8, talking about vectors, getting introduced to that. You may be familiar with vectors already from physics, you might not be familiar. I'm going to try to hit you everywhere where you're coming from with your knowledge. Really important thing though, in physics, you probably use degrees. Here in AP Pre-Calculus, we don't talk about degrees at all. Everything we do is radians based, so everything you see here is radians. Let's get at it. So first off, what is a vector? A vector is a line segment with the direction and magnitude. So it's got two things there. It can be written as a bold V, or since we can't write in V when we're writing, we just put a little arrow over it. So that's what that looks like. There's two forms. We have component form, and we have, which is that little, I call those chevrons. So it's where that A and B are between, not parentheses. They are chevrons. And then we have I and J form. So that's A times I. I is the horizontal unit vector direction. And then J is the unit vector vertical direction. So those are two different forms. So what is a vector? You can see it in the upper right-hand corner in those red words. We have some vocabulary here. We have the tail, which is where the vector starts. The head is where it ends. The direction, it goes from tail to head. And then the magnitude is the length of our vector. So to find the actual magnitude, see some formulas here. We can do the square root of each component squared, add those together. That's the magnitude. And then if you want to find out the individual components using the magnitude, well, you got those formulas right there. It looks very similar to polars because, well, everything is connected pretty much in the math world. So example one right here, use the graph below to find the component vector, component form, and magnitude of the vector. So let's go ahead and do this. I'm going to call this vector V. So that's how I draw. I just draw a half arrow because I'm just that lazy. So whenever we do this, we're always going to do head minus tail. So find the coordinate point of the head, which is going to be here at 7, 4. And the tail is going to be 0, 0. So this vector V in component form is going to be 7 minus 0 and 4 minus 0. And this is in component form. If I want it in IJ form, V is 7I, and instead of a dot, I just put an arrow, plus 4J. Again, instead of a dot, I just put an arrow. So same thing, component forms on the left, IJ forms on the right. I'll put a little components here. And then this is the IJ form. Okay, if you want to find the magnitude of that, the magnitude of this V, just some notation here. I can also write it as this. Now, magnitude, it'll be different than what you do in physics for what we do in AP Pre-Calculus and Calculus, is we use double bars to notate the magnitude. Just a little bit different. So this is going to be the square root of each component being squared, which is going to give me a root 65. And I'm actually okay with that number because it's a nice exact number. And let's move on. Example 2. So I'm going to give you the vector u. We're going to give us some parts about the u. If you look right here at the head, it's kind of hard to tell exactly where it ends. It kind of looks like it's in between a couple of the stuff. So let's find the exact values here. So we know that the magnitude is 15. We know that the radians value is going to be pi over 3. So it's going to be from here to here, what that's referring to. So let's go ahead and find what this vector u is. So for the A component, it's going to be 15 times cosine of pi over 3. From this formula right up here that I'm using. And this is going to give me 15 halves. And then for B, it's going to be 15 sine of pi over 3, which is going to be 15 root 3 over 2. Okay, so this is the vector u is 15 halves, comma, 15 root 3 all over 2. All right. Next example, now a little bit of sketching here just to kind of help us understand what's going on here. So example 3, given vectors u and v below, find the component form of u and v. So we're going to first do that. Do not forget that we are doing head minus tail. So I'm going to label these points of the head. So this u head right here looks like it's at -2, -2. this v head is here at 2, 0, and then this tail down here, it looks like it's at 0, comma 1, 2, 3, 4, 5, -5. So for the u vector, I'm going to do, it's head minus tail, so it's going to be -2 minus 0 for the first component. And then the second component is going to be -2 minus -5. So this is going to give me -2, comma 3. For the v1 here, we're going to get 2 minus 0, comma 0 minus -5, which gives us 2, comma 5. Okay, so that's that first part. I'll do the next part in red here. So if I want to do v minus u, I'm going to take v, and what I'm going to do here is where v, the head is, I'm going to draw that to be the tail of -u. So if I'm drawing this, if I'm going -u, I'm going to go the opposite direction than where it's going. So I'm going to go 1, 2, 3, 1, 2. And this right here gives me the opposite direction of u. So this is, I'm going to label this as -u. So from when v started to where we're ending right here, that's known as the resultant. That dotted line right there is the resultant. So I'm going to label that as R for resultant. So R, it's going to be the V, which is 2, 5, minus -2, 3. This is really the algebraic way that I'm doing it right now. So that resultant vector is going to give us 4, comma 2. So that's the resultant, which is V minus U. Okay. So what we're going to do now is we're going to take our same U's, our same V's, and we're going to go 2U plus V. So 2U has a greater length. Okay. So if I'm going to do this in purple now. So if I have 2U, if I multiply U by 2, that's going to give me -4, comma 6. Okay, so I'm actually going to start, just because I know I need a lot of space here, I'm going to start right here for this tail for 2U. I'm going to go left 4, 1, 2, 3, 4, and up 6. 1, 2, 3, 4, 5, 6 right here. And this is going to give me, let's make sure I count the right one. Yeah. This is going to give me the vector 2U. And then in green, I'll do V, which I know is 2, 5. Oh, kind of missed there a little bit, but not close enough. And then so in pink here is the resultant of that, which is going to be 2U plus V. Okay, so what is that? Well, we can just do 2U plus V. I have 2U right here, which is -4, comma 6, plus V, which is 2, 5. Put those together, and we're going to get that to equal left 2, so -2, comma, add those together, 11. All right, and there you go. Unit vector is when I have a vector that I want to keep the same direction and make its length just 1. Okay, so what we do with that is we find the magnitude and divide it by the magnitude. So in this example 4 here, you'll see the vector, we want to make this unit vector U. So real quick, the magnitude of 3, comma 5 is going to be the square root of 3 squared, which is 9, plus 25, which is root 34. So all we're going to do is to find the unit vector U. We're going to take each component and divide it by root 34. and that gives us a unit vector. So this is how to manipulate the length of a vector. Now, if I wanted this vector right here to have a length of 2, I would just take the unit vector and multiply it by 2. So the unit vectors are important so that we can manipulate what we want the length of a vector to be. Okay. Next up here, we're going to talk about the dot product, which doesn't really hold much significance as just a dot product, but it's very useful into other things. So the one thing we're going to use with it is finding the angle between two vectors. So the dot product is when you have, it's not multiplying. It's not a multiplying unit. It's a different type of arithmetic using vectors. So all the dot product is you take the horizontals and you multiply them. You take the verticals, multiply them, and then add those verticals and horizontals together. Okay, so the formula to find the angle between two vectors is right here. Okay, so let's go ahead and use this information to find the angle between 5, -3 and 6, 90. So I'm going to do 5, -3 dot 6, 10. So I'm going to get 5 times 6 and then add that to -3 times 10. So I'm going to get 30 plus -30, which is 0. So if I needed to find cosine, so cosine of theta is equal to 0 over who cares, right? Because it says I want to divide by the magnitude, but since I have 0 on top, the bottom doesn't matter. So when does theta equal 0? Quite a few times, but I'm going to say that theta is equal to pi over 2 because I'm talking about the angle between two vectors. Let's be realistic. These two vectors look like this, which creates a theta value of pi over 2. This means that these vectors are perpendicular. Well, that's not how you spell vectors. And when vectors are perpendicular, that means that they are orthogonal. New big old word there. Okay, these vectors are orthogonal. How do you know if vectors are orthogonal? It's when you do the dot product, you get 0. So whenever the dot product equals 0. We are orthogonal. Okay. Last example here, use a calculator to determine the angle between these two right here. So I'm going to do quite a few things here. I'm first going to find what 1, 2 dot -4, 5 is. It's going to give me -4 plus 10, which is 6. Oops. Oh, way down there. Okay, so I need 3 things. I need the dot product and I need the individual magnitude. So the magnitude of 1, 2 is 1 squared plus 2 squared, which equals √5. And I need the magnitude of -4, 5, which is -4 squared plus 5 squared, 16 plus 25, which is √41. So cosine of theta is equal to 6 over √5 times √41. So what I'm going to do here is I'm going to use my calculator here in a second, and I'm going to know that theta is going to be inverse cosine of 6 over √5 times √41. And this will give us our radian value here. And if you notice, just kind of putting things together here, inverse cosine is in quadrants 1 and 2, which means that these vectors are anywhere between here and then all the way open to through the second quadrant. So let's go ahead and go to our calculator. It says, uh-oh. Go figure. No, it's taking a little bit to refresh here. But again, all I'm going to do is, if this doesn't work, I'm going to just do it myself. Sign in. There we go. So I'm going to do, so that's for my parametric videos. I'll just go back to function mode. Okay. So I'm going to do second cosine. I'm going to hit alpha y equals enter, make this into a fraction. And 6 was on top. Square root of 5 times square root of 41. Let's make the end this fraction, and we're going to get 1.138. So our answer is going to be 1.138 radians. All right. I hope you enjoyed this video. Do not forget to like and subscribe.